So working on getting the second class loom something ready for our ignition class. And so starting to work all this out. Now, this is actually from when I went to Ignitions Trainings where I came up with this idea. And it's the smart cell. We do the finishing. We've always had the idea for a pick and place over here. That's never quite got done. And then this side over here was supposed to be for magnetic things, tooling, fixtures that could easily be swapped out. So that's what we're starting here. And so yeah, this is supposed to be an anodizing thing. That, well, I guess it's supposed to be RGB, red, green, blue. Okay, I guess I don't have my order right. But yeah, I'll work that part out. But so I have a banner stack light kind of hanging off here like it'll be a crane dipping something in. And when it dips down into the green, it should turn green, and then as you mix the colors, it will change that. And then later on, I thought we might even could make it where if you dip it for a certain amount of time, it puts so much green into it. If you dip it for a certain amount of time in the next one, you know, that way you can get true color variation. But right now, just trying to make it work. And like everything we do here, you know, you got to do it at least twice because this part looks really good. Looks like it's going to work, but we still finish parts with this. So now I need to get this connector out of the way, and I can't. So I need the world's cutest M12 connector, or world's smallest, but I don't think it exists. So for now I need to cut the cord off and manage to get this cable fished through. That way we can just unwire this and shove it up and out of the way when we're not using it. Yeah, we'll take a nice new molded cable. We're gonna go ahead and sacrifice it. And then I'll take my cable stripper, strip about yay much off of it. And then, then we were getting ready to go to the school of let's do everything twice because I was getting ready to put the end on it, but I need to fish it through the robot first. So we'll take a little tape. Who knows, maybe this is in the camera, maybe it's not in the camera, but I'm hoping I can just put a little bit of tape on where the wires are stripped. That'll be nice and thin. And I should be able to grab this. Oh, we're gonna have to do it twice anyway. I'm gonna take the cover off of it because I put a tie wrap up here to keep it from falling through. Not thinking very far ahead. So yeah, I'm gonna take the cover off of this. We'll get to look at the inside of it, and then I can cut the tie wrap and fish it through. I should be able to slide this off now. Well, there we go. Got that power cable on the way. Yeah, I did this tie wrap thinking that was a smart move, and now I realize it wasn't. Which actually, thinking about this in the future, because yeah, this probably will become a production trainer eventually. YRG has this pass-through. It gives you, I think, 15 wires, and probably that's where it needs to actually be done at, but I'm not sure what I'm doing yet, so we're going to do it this way. Now, for either efficiency or an unplanned learning opportunity, you never know until you do it, I'm going to try to strip all 4 of these at the same time. There we go. There we go. All 3 of them stripped at the same time. 4 of them stripped at the same time. And we'll slide this up on it. Of course, we should have done it before we stripped it because now we got a lot of fray wires to fight. And gotta love these connectors. We'll pop out the brown, the black, the blue, and while not used, we'll go ahead and do the white. That way it's at least terminated. And yeah, just slide them down in there and push in. And of course, I didn't think about I need some way to still hold this, but for now, because I bet you money, we're gonna have this apart at least 3 more times this week, maybe today. We're gonna stick a couple tie wraps here. If it was really smart, I would use a reusable tie wrap right now. And now we should be able to screw the part, which by the way, good job, Michael. Notice he even got the TW in there, but yeah, we have our round part that actually embeds that banner light. We'll hang it down. Ooh, and already I realize this needs to be much higher. So already we're going to cut those tie wraps off that I just put on, and we'll do it again. And in hindsight, I should have put a cord grip in here. And in one of the probably 5 times that we unwire this week for other reasons, I'll be sure to pop that in. And now I'm gonna plug this into port 1 of my 5032 module. Uh-oh. Oh, those things are tight. Oh, instead of going to get a screwdriver, I will just make my fingers hurt. And we'll go ahead and screw that in. And while I was at Automation Fair, I did get a little clarification. A lot of us have kind of gripe that you can't add devices on the fly on the 5032 module. But if you think about it, when you look at the actual memory structure you get by using the 5032, where instead of it, I was having to go to some particular data cell, getting that it'll be stack light color, you are adding all those memory points. And so I get the feeling that's why. Another one they brought up was safety. I'm not sure which it is, but let's see if we can get this added. And we're going to use that nice copy and paste feature, I hope. So actually, no, I'm not going to. Well, let's find out here. So if I right click the easy light, because this is the one easy light, all I need to do is make a second one on port 1. Yeah, we can copy. Got a little swirly wheel, right click. Oh, can't paste. Well, that's right. We got to double click on the module, the 5032 properties. Don't want to check. Is it change there? Ah, that's not quite intuitive, but yeah. So I was thinking the change here had mainly to do with the revision and everything. It looks like this is a separate area. Yeah, we click change there. And then port 1, we're going to make it an IO link port. And click OK. You're going to get a little warning that I probably should have read. But now, can we right click IO link? First of all, we have new module, but secondly, more importantly, we have paste. So I'm going to just try to paste that. And it came up as 2. Why did you come up as 2 when I thought I put port 1? That's right, I have to remember, it is port 1, but here it says C2. That's what it's going off of, because right now I'm using 0 and 8. And I'm going to call this the anodizing light. I'm going to Google how to spell anodizing. And now we should be able to download that. So communications, who active. And we'll download. So then I'm gonna have to make it where the robot picks it up to, simulate that it's picking it up. I'm not gonna dip it into here, but I'm just gonna move it over. So here, it'll be above this square and it should dip down into that square. I will turn it green. And then when we dip it in the blue, we'll have to blend the colors. So in the end, the goal will be, one, this just represent a process going on. But then we'll also have orders in there. So maybe order number 1, 2, 3 is going to be just a green. And then maybe 1, 2, 4 will be blue. And then 1, 2, 5 is a mixture of green and blue, which I don't know what green and blue make, but I'll figure it out. And so that's kind of hopefully the goal. So now I got to figure out, okay, I got a couple items. I got to program the moves, and I want to do the moves differently in this one. So already in our Smart Cell program, if we go to the robot routine, then currently we are using the execute program. So what this is doing is it's just passing the program start over to the RCX software by Yamaha. And in this case, we're just running this one program. And this is really good because we have like 300 points to run. The other cool feature that my buddy over at Yamaha, Chris Elston, everybody knows him, Mr. PLC did, is he realized, hey, a lot of us are PLC programmers. We're not really code line programmers. So also directly in ladder logic, you can tell it, go to this position. And I think that's what I want to do on this one. That way, because part of what we do in this training is try to sprinkle in different things you can do. So we already have an example of how you a really involved point program, which there's no doubt. In those cases, you cannot beat this way because mainly if we go to our points, if I can figure out where the points are, there's somewhere in here. I'm a little rusty on this. I need to get in here and play with this. Oh, if Chris Elston's watching, he's probably screaming at me saying it's right there. There we go. But if we go to the point program, mainly in this case, we can copy and paste out of Excel. And for this many points, you can't beat that. But in this one, I think I'm going to use a two-dimensional array and go ahead and put my coordinates into Studio so we can show how you could have everything in Studio, and we'll run this one that way. Yeah, over on YRG Inc.'s site, they have a really good add-on instruction library. In fact, here's all the add-on instructions, a bunch of them. But let's go back up here, and I think it's this one. Let's go into here. And yes, so we want to move, I don't want to move point. That's kind of what we're already doing. We're running a program to do that. Advanced move point, move millimeter. Here's where I may have to call Chris. I don't know if I want to move millimeter, move advanced millimeter, or move, oh, now I got too many choices. Oh, let's just go check one of them out there. Yeah, so here's what I want to be able to do is we're going to feed these in through an array depending on where we want it to go. So yeah, need to figure out how to work that out. Got to borrow Amber's car to go get a haircut. You know, nothing keeps you limber for crawling under a machine like trying to fight your way into your wife's car who was a foot shorter than you. Now, if it was really good, I could stare at this screen, snap my fingers, and haircut done. Better stick to PLC programming. That wasn't really good. So I don't have this one in here, so we're going to import it in. So I'm going to right-click Add-on Instructions, Import. The M3 move MM, I think that one's it. We're going to go ahead and bring that thing in. And okay, probably should have read the instructions. We're just going to go for it. All right, I already have a move here to move to a specific point, but what I want to do is move to a position. So we're going to go ahead and bring a new rung down right beneath it. Let's see, we're going to go find the AOI. Oops, apparently I scrolled. Did I close it? Nope, still highlighted. So if you didn't know, you can actually drag these in from the left side too. We're going to drop that one there, and then I'm going to fill out some tags. Now I'm not 100% sure what I need here for these axes yet, so I'm going to create an array. So let's go ahead and just right click there, new tag, and I'm going to call this my anodizing positions. And this is going to be a real data type, but I'm going to hit the dialog box to the right of it. And so I know I need 4 positions. We're not actually using the 5th and the 6th one here. I can put zeros on those over here. But I'm going to use 4, and then I know I need a color. And then I feel like I might need something else, and I don't want to have to re-download. We can always clean it up later. I'm going to make this a dim 0 of 6. That'll give me 1 extra spot, and when we do that, dim 1 comes available. Now I got to think through my positions. Whoops, put my hand in the light curtain. But so we have our empty position, then we're going to raise up. So that'll be 0, 1, 2, 3. I argue go back to 3, but I'm going to make this 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 15 total. I'm gonna make it 20. So dim 1 will be 20. And we're gonna work with that later, but mainly this gives us a starting point on some of this. We're going to create that. And then for this one, for now, I'm gonna put in anodizing positions 0, 0. Actually, we'll make 0 the color, because that'll help us keep track of where we're at. Well, I guess it doesn't matter, but yeah. And then the next one we're gonna make 1, or no, we'll make 2. And then the next one we'll make 3. And the next one we'll make 4. And then the 5th one, I'm just going to put a 0 in. I think a 0 will work fine there, and a 0 will work fine there. Now we do need a speed, and there you go. I probably should have put a speed in there, but I'm just going to make a tag called anodizing speed. And we'll right-click that, new. And it says that needs to be an integer. And then we got our map robot inputs and outputs, which I already can grab the instruction right above it. So we'll grab that one. All right, so now this instruction's happy. I'm not even sure how we're going to drive this instruction yet. I'm just trying to figure out how to even do any of this. So I'm just going to put this in as, and boy, by the end of this video, I'm going to figure out how to spell anodizing. So anodizing test move. That'll get us to where we should be able to do something. Now I need some positions, and I actually already have another instruction in here, which one, I need to revise this one. They have a really cool RTO feature in here now that I don't even need to use some of these add-on instructions. But we go down here to rung 21-ish. Yeah, we're sequencing through getting some alarms and some various things, and here is our current position. So I should be able to put these rough values in and get to this exact value. So we're going to say 70, 165, we'll call that 60, and 130. So we're going to make this one 70, and then 765, 60, and 130. And then when we toggle this, we should see the robot move to the exact position. And just in case I really screw up, let's look this way while we toggle it. Well, and it didn't do anything. And that's because it's going to do exactly what you tell it to do, and it is trying to go there with a speed of 0. That is never going to work. So now the question is, what speed do we normally run? I don't know, but looks like on this earlier test we were moving at 20. So we're going to put a speed of 20 in here. And then we toggle it. It works a lot better when you give it a speed. So I put these in as fixed numbers. So already now that we have 1 down, now we need to go to the next position. But okay, so now we're going to index through a value here to figure the rest of this out. That way we can actually test the positions. So we're going to start a rung edit here. And actually before we do that, which one, if you didn't know, if you didn't know, anywhere on your rung, like if I even clicked over here, you can hit Control W to create a tag, or we can go over here in the left pane, right click, and there's that Control W shortcut. We're going to create a tag. And we're going to call this one anodizing. Oh, why did I should have called it the paint tank. I could have spelled paint. Anodizing. This will be our position index. And double integer will be a fine on that. Oops, let me get a capital P right there. Yeah, I can type faster, but I'm holding the phone with the other hand. And so we create that. We're going to double click on this one, and we're going to put in place of that 0. Oh, why does the paste not work? Oh no. Paste. There it goes. Well, that was weird. I couldn't control V it. But okay, so what this is going to do is going to substitute whatever number I have here. That's going to let us start working through our positions. So take that one out, which I should have thought. Man, that's a tough aim there. Paste that one. Do it a couple more times. I don't need to be bored with that. I'm going to hit the pause button. So we're going to go back over to our RCX Studio. And we're just going to use the jog, and we're going to bring A3 up. So I just wanted where it's going to clear that. Oh no, it doesn't work. Oh, darn safety reset got me again. There we go. Then we'll come over here and try it again. Oh, and look at there, it even tells us, hey, your e-stop is on. Yeah, it was. Thanks for telling me. Now, if we retract that. Oh, no. Well, I didn't think this through well. It did retract, but this piece needs to be coupled to this. Not up here. Now in the end, I'll get Michael to make some type of cord set to kind of do that. There's our nice fine mount. And now when we retract it, oh yeah, that looks much better. Oops, except for it slipped. Now we did some fancy pants sequencing logic here, and if everything works right, no reason not to record it on our first trial, then when we go anodizing run process, one, the light should turn white right away. Oh, okay, well there's our first problem. The light did not turn white. Although in this camera it almost looks white, but that is green. I should come over here. Oh yeah, that totally screwed up my light. Yeah, I'd say that light is not working at all. What did I do wrong? Well, look at the rest of it though, folks. Kind of looks like it's almost doing what it's supposed to do. Definitely need a little more speed on that probably. What do you think, Mary Bruce? Yes. Yeah, we'll speed it up in the next one. Now let's see if it actually comes over here. It should kind of act like it's dropping a part off. And actually at the end of that, the light should go out and then it'll pick up, and that is the end of that cycle, and it should come back over here and be ready for the next cycle. Yeah, we need a little more speed to get a little bit of excitement out of that. Between there's a lot of dwell time to think about things. All right, found a nice copy and paste error. That was supposed to be position 0 of our index. I had as position 2. And then, yeah, let's see if we can go ahead and speed this up a little bit. We're at 20. Well, let's go ahead and make it 50. I get a nice little giggle from Mary Bruce because she knows that chances are we're getting ready to do something really dumb, but you know, why not go ahead and record it and put it on YouTube? So now we'll try it. Oh, it's definitely going to the wrong place. I don't even know where it's going now.
Let's just watch it.
Yeah, we might need to stop that. Yep. Oh, there it goes. All right, so we got one craziness going on. I'm not sure, but hey, look, we got a white light now. Look at that. Okay. Yep, see, red in the wrong spot. Oh, I'm off by 1 the whole time. Okay, got a little work to do on my timing. Actually, that's a little fast, I gotta admit. That's gonna be hard to talk out. And I don't know where the first position is, but definitely gotta find it. Okay, I think we've got the initial part. Now, in the end, I've gotta make it where you dip it into red and green and it makes brown. Brown or is it yellow? She's the art major, she's probably right. But we got to figure all that out. But for now, just to represent our process, if we toggle that run process, it's going to come down. It's going to light up to tell us that it's picked the part up. Comes over, and if it dips it into the red, it'll turn red. And if it dips it into the green, it'll turn green. And if it dips it into the blue, it'll turn blue. And then just to represent us going over and dropping the part off, comes over here, light turns off, and it's ready to do it again. So I think that'll be a really good visual for us to talk about SCADAs and writing programs in Ignition in our upcoming class, which, by the way, there'll be a link to down in the description.